I mean, so there's a couple of places. I mean, I think, starting off with just what you've shown over here, if you're dealing with a rural municipality, well, even these days with a lot of large municipalities, you're dealing with multiple settlements. I mean, take a Mangong, you've got Botshabelo, Tabanshu, Bloemfontein. And I mean, if there was a perfect distribution of facilities between different settlements, you would then be able to kind of say, well, okay, these are the areas that are best served. So, for example, let's say you're trying to work out where to create planning regions within the municipality, whether you're trying to create, service regions. But I mean, I think for me, Thiessen it's a starting point, because what you would say, for example, is, should we invest in town 1, 2, or 3? Which is the population in those towns 1, 2, and 3, for example. If you had, let's say someone's a farmer and they're going to travel into town to the nearest Pick and Pay, if town A is 20 kilometers away and town B is 15 kilometers away, logically you would say that they will most likely go to the closer town. But that doesn't always hold true. So sometimes Thiessen's polygons kind of help tell us things about the towns. If someone is driving an extra 5 kilometers to go to another town, as opposed to driving extra 5 kilometers to go to town A as opposed to going to town B, then what is it about that particular town that that has a stronger attractor, for example? So, I mean, I think Thiessen polygons, it's a kind of a starting point, and then kind of starting to work out what can you do to kind of give gravity weighting to them. If you had to map where all the different Pick and Pays are within the municipality, would that, and use that as a gravity weighting, would that help explain why people make the travel decisions that they do? That's one place I could kind of see it's kind of value. Administrative regions, but also trying to work out what is the pull factors and push factors within a municipality in terms of how people travel, where they go to. I know another place that we've some usage of was looking at, for example, informal settlements. And if you had to take a point of each of the different the shacks within the formal settlement, it will basically give you an idea about what is the area around each shack that they have usage of. It's obviously not as simple as that, because there's often a lot more common usage, etc. But I mean, for example, if you're trying to work out what is a just distribution of land within a informal settlement or upgrades, starting with something like a Thiessen's polygon would give you an idea about which areas of the informal settlement have smaller effective earth sizes and which areas have larger effective earth sizes, which would kind of give you the base information for trying to almost reallocate land. I could talk a bit more of that if you want, but yeah.
Yeah, thank you, Stuart. So what you're saying this is a starting point for analysis, and later on with your next round of analysis, you can add or must add then a type of a gravity, like population or types of business or number of business or income per town, to get a better picture of distribution or then development in certain areas.
Yeah. I mean, all things being equal, you would expect people to always take the shortest routes, but things aren't equal. And I think then it's also you using kind of gravity factors to work out what explains people's kind of movement patterns, or what explains, for example, distribution. Let's say you're trying to work out where to invest housing in a particular municipality, and you've got 5 different towns to choose between. The mistake that's often made is people simply say, well, here is where people are, therefore that's where we're going to put the houses. Whereas if you might find in a particular town that a certain area might have a stronger economic gravity and another one might have a stronger population gravity, in that case, you then have to work out what makes more sense, to put it where the people are, or to rather expand on another town that might have stronger economic facilities as well. And making sense of what makes better explanation with it. So I mean, I think it's not you wouldn't want to basically say, kind of do a Thiessen's polygon exercise and simply say this is what it is, but you'd use it as a way to start identifying why do certain things happen, why do other things not happen, and and from there to start using that to kind of make decisions as well.
How to create Thiessen polygons in QGIS. We are going to use towns in the Free State as an example to create Thiessen polygons. In your processing toolbox, you can search for Thiessen. It is the same as Borneo polygons. The extent of the study area will be the whole Free State of this map. So we're going to use 100% of the extent. I'm not going to save it, but we can save it as a geo package, as a shapefile. But for this example, I'm going to leave it to create a temporary layer. So I'm going to run this function. So here is the Thiessen polygon structure for towns in the Free State. You can now clip it to form part of the Free State boundary. You can make it change the symbology to make it more clear where the boundaries are. So this is how you create Thiessen polygons. Important to note again is the projection of the layer and which percentage of the extent do you want to use for your Thiessen polygon. The data that we're going to use to create the catchment area is firstly the towns in the Free State, and secondly the road network that is routable for the Free State. First things first, for the process to work, the points or the towns needs to connect to the road network. In this case, you can see it does not connect. So what we're going to do is we can run the snap to function, snap geometries to layer. The input layer will be this towns layer, and then the network FS roads 35S will be the reference network. Let's make the tolerance 100 meters. I'm not going to save it, so only a temporary file. You see now that snapped to the road network. Just want to zoom out again, and now we run this process from the plugin queue need 3, the ISO area, and this one, the ISO area as polygon. Not that one. From layer, so the network will be this 35S, FS roads. The start point will be the snap geometry. Let's make that 250,000, but to speed up the process, let's make this say 20,000 or 20 kilometers, the size of the interval. The cell size, we can keep that at 100, and let's run it. And here are the catchment areas for the towns in the Free State. As you can see, the polygons or the layer needs a little bit of work. Let's symbolize it. Categorized with let's do it in a blue color ramp. The value that we're going to use is this cost level. I just want to invert the colors. So you see nearer to the towns, the darker blue, and you can now cut the boundaries to make. Let's see. Let's switch it off. Here's the raster. Yeah, you can cut off the boundaries here to represent the Free State boundary. But this is the then a catchment area for towns in the Free State.